function generator, right? There is ICL8038. So what's the function generator? So what is the function generator? So what's the purpose of function generator? Generates the basic waveforms, right? So square wave, sine wave and triangle wave, right? Then what are the applications of this function generator? So they use them telemetric, then electronic music, communication and testing and calculation in the lab, right? Then we have discussed about the basic principle of this function generator, right? So what's the basic principle? So the function or working of the function generator depends upon the charging and discharging of the capacitor. Since this function generator generates the basic waveforms, they are also known as waveform generators. Since the function generator generates basic waveforms, they are also known as waveform generator. Then the function depends upon the charging and discharging of the capacitor. Then the charging and discharging of the capacitor controlled by current IA and IB, right? So charge is controlled by the current IA and discharge is controlled by the current IB, right? Then listen, so you are seeing the basic principle of this waveform generator, right? So we are going to discuss about the circuit diagram of the waveform generator. So here we have transistors, then we have a buffer, then we have a comparator, then we have a flip-flop, right? So listen. So normally the function of the function generator, waveform generator depends upon the charging and discharging of the capacitor, right? So see, this charging and discharging of the capacitor is controlled by the currents IA and IB respectively. So these magnitudes are controlled by the current IA and IB respectively. So listen. So here the transistors Q1 and Q2 form a programmable current source whose magnitude are controlled by the current IA and IB respectively. So transistors Q1 and Q2 form a programmable current source whose magnitude are controlled by the current source IA and IB respectively. Right? Then transistor Q3 will act as a emitter follower circuit. So transistor Q3 will act as a emitter follower circuit. Then it also compensates the base emitter voltage drop on the transistor Q1 and Q2. So the transistor Q3 will act as a emitter follower circuit. Then so there will be some voltage drop at the base emitter transistor. So there will be some voltage drop across the base emitter transistor of Q1 and Q2. So it also compensates that voltage drop. Now write it down. The voltage drop across the transistor Q1 and Q2 is given by, so VRA equal to VRB is equal to VI. So this is the voltage drop across the resistor RA. So this will be the voltage drop across the resistor RB and this will be the total voltage. So write it down. So we know that V is equal to IR, right? So from this what is IA VA by RA, right? So what's IB? VA by RB. So this is the voltage drop across the transistor Q1 and Q2. We already know that V is equal to IR from this IA, right? So IA is equal to VA by RA and IB is equal to VA by RB. Write it down. The current IA will control the charge rate of the capacitor C. So the charge rate of the capacitor is controlled by the current IA. Right? Then the current IA will be divided into transistors Q4, Q5 and Q6. So the current IP will be divided into transistor Q4, Q5 and Q6. The current IP will be divided into the transistors Q4, Q5 and Q6. Completed? The current IP will be divided between the transistors Q4, current I will be divided between the transistors Q4, Q5 and Q6. So here it undergoes polarity reversal as well as amplification by a factor 2. So hence the net current will be, net current flowing through the transistors will be 2 IB. So completed. Listen. So voltage across the capacitor C will be applied to the current trigger, right? So voltage across the capacitor C will be applied to the circuit trigger, and this Q sub transistor will always act as a switch. So the voltage across the capacitor will be applied to the circuit trigger, and the transistor Q7 will act as a switch. Completed. Then listen, when the output of the flip flop is high, the transistor Q7 saturates. When the output of the flip flop is high, the transistor Q7 saturates and it makes the transistor Q5 and Q6 become a low value. So when the flip flop output is high, the transistor Q7 saturates. Transistor Q7 saturates and pulls the base of the transistor Q5 and Q6 as low. So as a result of this, the capacitor C starts to charge. It is converted by the magnitude current IA. So as a result of this, the capacitor C starts to charge and its magnitude is converted by the current IA. Completed. See, listen. So we have two voltage level, right? Upper threshold and we have a lower threshold voltage level, right? Listen. So when the capacitor voltage reaches the upper threshold value, that is 2 by 3 of VCC, the comparator 1 starts to trigger and clear the flip flop. So by this, the transistor Q7 will get off. So when the capacitor voltage reaches the upper threshold value, that is 2 by 3 of VCC, comparator 1 starts to trigger and will clear the flip flop, and due to this, the transistor Q7 will go off. Right? So due to this, the net current is given by IL is equal to 2 into IP minus IA. Then, as a result of this, the capacitor C starts to discharge. So completed. So next, when the capacitor voltage reaches the lower threshold level, that is 1 by 3 of VCC, the comparator 2 starts to trigger and clears the flip flop, and the process gets repeated. So when the voltage of the capacitor reaches the upper threshold value, the comparator 1 starts to trigger, clear the flip flops and make the transistor Q7 off. Then this is the net current and this will enable the capacitor to discharge. Then when the voltage of the capacitor reaches the lower threshold value, that is 1 by 3 of VCC, the comparator 2 starts to trigger, clears the flip flop, and the action gets repeated. Listen, always the net current flowing through the capacitor should be positive. So net current flowing through the capacitor should be always positive and is given by 2 into IP minus IA greater than 0. So you can also write this as 2 into IP greater than IA. So net current flowing through the capacitor C must be always positive. Write it down. Completed. Next, put the heading as frequency of Next, put the heading as this is the continuation of this topic. Put the heading as frequency output waveform. Completed. Listen, now you are going to determine the frequency of the output waveform. So the current value of the capacitor is given by, so I is equal to C into dV by dt, right? Then we can write as dV by dt as C into Tc is equal to del into Vc divided by charge current del into Vc is 1 by charge current into C. This is the charging time of the capacitor. So completed. So it's very fast. So charge current is nothing but Ia. So it's Ia. So it's Ia. VI by RA. What is there in the VC? Charging time. What is the charging time of the capacitor? What is the charging time of the capacitor? 1 by 3 into VCC. Write it down. 1 by 3 into VCC into 1 by VI by RA. Getting C into RA into VCC by 3 into VI. Answer is equation number 1. This is the value of DC, right? This is the value of DC. Next you have to find the value of TD. Write it down. The discharging time TD can be given as the discharging time TD can be given as so TD can be given as write down del into Vc into 1 by discharge current into C. Write it down. The discharging time TD can be given as del into Vc into 1 by discharge current. Discharging current. Boys, let's stop talking. Into C. VCC by 3 into 1 by, you are getting 2 into VI by RB minus VI by RA into C. getting C into RA VCC by 3 into VI into RB by 2 into RA minus RB. Consider this equation number 3. So multiply and divide by RE in the numerator and denominator 4 times. So multiply RA in the numerator and denominator, solve it and get this answer. So this is the value for TD. Now you know the charging time and discharging time, right? So substitute this in the total time. There is T is equal to TC plus TD. Substitute both the values. Simplify it and tell me the final answer. We know that T is equal to TC plus TD, right? So you know the value of TD and TC, right? So substitute both the values, simplify it, solve it and tell me the final answer. So we get it C into RA into VCC by 3 into VI 2RA by 2 into RA minus RB. So answer is the equation number 4. So now we have calculated the total time, right? Then write it down. We know that F out is given by 1 by TC plus TD. We know that this is the frequency of the output waveform. So it is given by 1 by charging time plus discharging time. So you know the value of TC plus TD, right? Substitute this and tell me the answer. Reverse. What is the final answer? 3 into VI by C into RA into VCC into 1 minus RB by 2 into RA. Got this answer? So you are getting this answer in the denominator. Bring that answer to the numerator side. So take this as equation number 6. This is equation number 5. Frequency of this is equation number 5 and then equation number 6. Write it down. Duty cycle is given by charging time plus discharging time into 100. So this is equation number 7. So you know the value for TC and TD, right? Substitute it, simplify it and solve it. So you know the value for charging time as well as discharging time. Substitute the value, simplify it and solve it. With this answer. Simplify by answer. So at first we get 1 minus RB by 2 into RA into 100. So consider this equation number 8. Completed. So write it down. Where RA is equal to RB, where RA is equal to RB, the duty cycle will be 50%. Duty cycle will be 50%, and we get a symmetric waveform. So when RA is equal to RB, the duty cycle will be 50%, and we get a symmetric waveform. Then equation 6 can be written as to RB. Equation 6 can be written as F of is equal to 3 into VI, CA into RA, the BCC 1 minus RA by 2 into, so instead of RB substitute, so listen, when RA is equal to RB, equation number 6 becomes 3 into VI by 3 into RA into BCC 1 minus RA by 2 into RA. So replace RB by RA, 2 into RA. So since RA is equal to RB, listen, to cross multiply this, so we get 2 into RA minus RA by 2 RA, right? Simplify it, I will be getting the frequency of the output waveform as 1.5 into VI divided by C into RA into BCC. So this will be equation number